So there's actually 3 different ways of writing an equation or a linear equation. 3 different ways. We've talked about slope-intercept form, and we've talked about point-slope form. So finally, the last thing we're going to talk about today is what is called standard form. Standard form looks like ax plus by equals c. A and B and C are all going to end up being numbers. So A, B, and C will all be numbers, and the x and the y will still be there. But basically, it's if you see x and y on the same side of the equal sign, that is standard form. Something that we also want to make note of when we are talking about standard form is that we want A and B something about standard form is that we want A and B to be integers, and we want x or A to be positive. Okay, so we're going to get into that, but I want you to write that down. A and B are integers, and A is positive. So A and B are integers, and then we also want to make note that A is positive. Okay, so that's going to come in handy in a little bit. Okay, so before we get started, we're going to be talking about x and y intercepts, and we've already talked about the y-intercept, but we need to talk about the x-intercept first. So turn to your vocabulary page. So we do have one vocabulary word. We've already talked about the y-intercept. It's where the graph crosses the y-axis. So the x-intercept is the x-coordinate of a point. Where the graph crosses the x-axis. Okay, so it's the x-coordinate of a point where the graph crosses the x-axis. So let's do an example. So I'm going to draw a little graph. And I'm going to do a line through here. Guys, what is the coordinate of that not very pretty looking graph that crosses the x-axis? It's at 2, comma what? 0. So the x-intercept is going to be right here at 2, comma 0. Now the official definition says that it's just the x-coordinate, so we would say that the x-intercept is what? What's the x-coordinate? 2. So the x-intercept is 2. So using that definition, anytime you see a line or the equation of a line in this form, you're going to graph it using x and y intercepts. So we're going to do an example. 3x plus 4y equals 24, so that's going to be the example that we're using. Let me do a different color. So we want to find the x and the y intercepts of this. So the first thing we're going to do is find the x-intercept. By substituting something in for y and solving for x. Looking back at the definition, look at the coordinate of this x-intercept. What is the y-coordinate of the x-intercept? 0. Do you think that will always be the case? Yeah, because on the x-axis, the y-coordinate is always 0, right? Because you don't have to go up or down at all to get to the x-axis. So to find the x-intercept, we plug in 0 for y, and then we solve for x. So we're going to do that. So for 3x plus 4y equals 24, I'm going to have 3x plus 4 times 0 equals 24. Guys, what's 4 times 0? 0. So this is just going to be 3x equals 24. And how do I solve for x there? Yeah, divide by 3. So we would get as an answer x equals what? 8. That's your x-intercept. If I wanted you to write it as a coordinate, it would be 8, comma, what did we plug in for y? 0. Okay. So how do you think we're going to find the y-intercept? So to find the y-intercept, we're going to substitute 0 in for what? For x and solve. So I want you guys to do that right now. Okay, so we plugged in 0 for y. 3 times 0 is 0, so we got 4y, or sorry, we plugged in 0 for x. 3 times 0 is 0, so 4y equals 24. Divide by 4, and we get y equals what, everyone? 6. Okay, now this is the y-intercept. So if I were to write this as an ordered pair, what did we plug in for x? 0. So it's going to be 0, comma, and when we plugged in 0 for x, we spit out what? 6 for y. Okay, so finding the x and the y-intercepts, you're actually finding two different coordinates, and we're going to use those to graph. Make sense? So what we're going to do is practice a little bit with x and y-intercepts, and then we'll actually graph using the intercepts. So to find the intercepts, anytime you see x and y on the same side of the equal sign, we are going to be using intercept. I like to use a T-chart. So underneath the equation, I always write a T-chart. And I label the left side x-intercept. And in math, we use x-int for intercept and y-int for y-intercept. And then I find my x-coordinate on the left and my y-coordinate on the right. So let's do this really quick. To find the x-intercept, I plug in 0 for y. So that's going to be 5x minus 6 times 0 equals 60. 6 times 0 is what, guys? 0. So that's 5x equals 60. And how do I solve? Divide by 5. So x equals 12. So let's write that in. My x-intercept is at 12. And then underneath, I'm just going to write 12, comma 0, just so that I don't forget. Let's do the y-intercept. The y-intercept is where x equals 0. So that's 5 times 0 minus 6y equals 60. Okay, here's where I want everybody to make sure you are paying attention. 5 times 0 is what? 0. So 5 times 0 is 0. It goes away. What is left? Negative 6y equals 60. Okay, that negative does not go away, because we're really doing 0 minus 6y, which is negative 6y, right? Okay, divide both sides by negative 6, and I get y equals negative 10. which is actually the coordinate 0, -10. And my y-intercept is at -10. Not too bad? Okay, I want you guys to do 2 and 3 for me really quick. So, on the left is Melody's number 2. She found the x-intercept to be 8 and the y-intercept to be 3. Look at her work. Do you agree or disagree? Thumbs up for agree, thumbs down for disagree. I agree, 8 and 3. And then number 3 is Christian's. He did the x-intercept as 3 and the y-intercept is -21. Thumbs up, we agree. Thumbs down, we disagree. I also agree. Number 3 is tricky because when you plug in 0 for 7, you get -y equals 21. But remember, we always want y, our variable, to be positive when we are solving. So he divided both sides by -1 right here. That should be negative, right? And then y equals -21. Good. Okay, questions or concerns? Okay, let's move on. Let's actually use this to graph. Okay, so looking at number 4, let's find the intercepts first really quick. So I have x minus 2y equals -2. So let's make our t-chart. X-intercept, y-intercept. X-intercept is where y equals 0. So this is going to be x minus 2 times 0 equals -2, which just gives me x equals -2. So that's the point, -2, 0. My y-intercept is where x equals 0. So that's going to be 0 minus 2y equals -2. So -2y equals -2. Divide both sides by -2. So y equals what? +1. Oop. So my y-intercept is at 1, and that's the point 0, 1. Okay? That was kind of fast. Is everybody with me? Okay, how the heck do we use this to graph? What could I do? Karina.
You could plot the points and find the slope.
You don't even have to find the slope. We can plot the points and draw a line through them. 2 points is enough to make a line. So let's plot the x-intercept. And this is actually why we don't always use the coordinates, like the ordered pair, to write the intercept. Because at -2, 0, that's right here. If I just say my x-intercept is -2, I know that along the x-axis I'm going to go left 2 spaces, right? If my y-intercept is +1, where along the y-axis will I go? Up 1. So you would do a point at +1 on the y-axis. Is that enough to draw a line? Yeah, so we're going to draw a line straight through. If I ever asked you to find the slope, could you find the slope from this graph? Yeah, we would count rise over run. And in this one, we go up 1 space, right how many? 2. So what actually would be the slope? 1/2. Good. I'm not asking you to find that. I'm just pointing it out. So here's what I want from you guys. 5, do it. 6 and 7 are on the next page. Do those for me as well. Okay, so let's check what we got. This is Kiki's number 5. She got the x-intercept is 10 and the y-intercept is 4. There's her graph. The graph that I gave you, I think it only goes to 9. So her x-intercept went 1 off the graph. Okay, and then her y-intercept is up 1, 2, 3, 4 places. Thumbs up if we agree. Excellent. Okay, let's look at number 6. Whose number 6 is this? AJ's? AJ got the x-intercept is -8 and the y-intercept is +8. And his graph shows an x-intercept -8 spaces to the left and the y-intercept as 8 spaces up. And then he connected those. Thumbs up if you agree. Excellent. And then this is Karina's number 7. She got the x-intercept is 3. The y-intercept is +9. And that is her graph. Thumbs up if you agree. Thumbs down if you disagree. I think I disagree on one. Jen, what do you think? Negative 9. So positive 18 divided by negative 2 comes out to, negative 9. So our y-intercept should have been down here. X-intercept is here. And then we draw the line. The only other thing that I would fix on this one is right here, we're trying to isolate the y, so we would just divide by negative 2, not negative 2y. Okay, so it's just divided by negative 2. Okay, so we should have got negative 9 as our y-intercept. Okay, everybody in agreement now? Okay, great. Let's move on. Horizontal and vertical lines are two special types of lines, and we have talked about them a little bit, but we can actually write them in standard form. So I want you guys to just be aware of this because it actually is going to help you graph them. So if I give you the line x equals positive 3, is there a y in there at all? So we can rewrite this as x plus, what would I multiply by y if it's not there? 0. So this would be plus 0y equals 3. And let's think about why this makes sense. 0 times y is what? 0. So it's actually not there, but this is a placeholder so that we can put it in standard form. So then how do I graph this? My x-intercept is going to be what? 3. So I put a line at 3, a point at 3. Will my graph ever cross the y-axis at all? No. Why? Y doesn't exist in this one, right? It's 0. Another way we can think of this is if you were to draw like a t-chart for your x's and your y's, x always has to be what number? What does the equation tell us? X is always 3. So I could plug in 1 for y, 2 for y, 3 for y, and I always get what as my x? 3. So I could plot these points 1, 3, 2, 3, 1, 3, 2, 3, 3, and what type of line do I get? A vertical line. So if I ever get an equation like x equals 3, you can rewrite it as x plus 0y equals 3. We know my x-intercept is going to be at 3 because it says, right? We know it's never going to cross the y-axis because y doesn't exist in this equation. So it has to be parallel to the y-axis. Okay? So those are vertical lines. Follow-up question. Are vertical lines functions? No. So let's talk about when I have just a y equals. How would I rewrite this one in standard form? I have y equals 3. Jen? 0x plus what? Plus y equals? Okay. Does this equation have an x-intercept? No, x does not exist in this equation because it's 0. So it cancels or goes away. So what is my y-intercept? 3. Since this line does not have an x value, what type of line would we get? Horizontal. So it's never going to cross the x-axis. You could do the same thing if you get stuck, do an x and y t-chart. If I plug in 1 for x, what am I going to get for y? If I plug in 2 for x, what am I going to get for y? If I plug in 3 for x, what am I going to get for y? And if I plotted those points, they would make a horizontal line. Okay? So if you ever get stuck, you could also make a t-chart. Okay? Those are special types of lines. So let's say I give you the equation of a line, and I want you to put it in standard form. So for example, y equals negative 3 over 7x plus 5, and I want you to put it in standard form. First of all, that fraction is really throwing things off. So I want to get rid of the fraction. How can I clear the fraction? What would I multiply by? 7. So you are going to clear the fraction using distributive property. And then it says if needed. This is only if there are fractions. So if you are given an equation of a line and the slope is not a fraction, you won't have to do this step. Okay? So I'm going to multiply both sides by 7 in the example. And whatever I do to one side, I have to do to the other. So 7 times y gives me what, guys? 7y equals... this is the distributive property. So when I multiply negative 3 over 7 times 7, what happens to the denominator? It reduces. So we are left with negative 3x plus 5 times 7, which is 35. Second step. We are going to use inverse operations to isolate the constant. Constant is the number. And then big note right here, make sure x is positive. Okay, so you're going to have to do whatever it is you need to do to make sure x is positive. If I want to move this x to the other side, what am I going to do? Right now it's a negative 3x. What am I going to do? Add 3x. So I'm going to add 3x to both sides. Because they will add up to 0 on the right. 3x and 7y are not like terms. So that's going to stay as 3x plus 7y equals 35. Is the x value positive in this problem? Yes. So we are done. And an equation of the line in standard form is 3x plus 7y equals 35. Okay. Okay. If it is not positive, so what would I do? Let's say I had to subtract 3x and I got negative 3x plus 7y. What could I do to make that 3x positive? Yeah, you could divide every single item by negative 1. So you'd have to do everything divided by negative 1. So it would change the signs of everything. Okay? I think one of the examples that does happen. So what I want you guys to do is try 10 and 11 on your own. So number 10, I have my slope as 1/4. So guys, the first thing I should do is multiply the whole equation by what? By 4, so that the denominator reduces. So that's going to give me 4y equals 1/4 times 4 reduces. So I'm left with 1x minus 8. Thumbs up. You're with me so far. Okay, good. Okay, who can tell me what they did next? Faith, what'd you do next?
I added x to both sides.
You added x to both sides? Oh my gosh. So plus x. Question, x plus x gives me what? 2x. So did that cancel? So what could I do to make the x's cancel? Subtract. So minus x. Guys, x minus x gives me 0. So I have negative x plus 4y equals negative 8. Is that what I want? No. So the thing about standard form, x's always come first because remember, mathematicians like things alphabetical. But we also want the x to be positive. So what could I do to get that negative x and turn it into a positive x? Rose. I subtract negative 1? Divide by negative 1. So I divide the whole thing by negative 1. And watch what happens. Negative x divided by negative 1 gives me positive x. 4y divided by negative 1 gives me negative 4y. So remember, I'm dividing everything on the left. Negative 8 divided by negative 1 gives me positive 8. And that's my standard form. Okay? Questions or concerns? Okay, on number 11, that didn't really happen. We would multiply everything by 3, and we would get 3y equals negative 2x minus 3. Really, I think the biggest mistake that you might run into is forgetting to distribute the denominator. So remember, you have to multiply the 3 times the negative 1. And then to move the 2x to the other side, we add 2x. Because negative 2x plus 2x is 0. So that gives me 2x plus 3y equals negative 3. Is that in standard form? Yep, so we are good. Okay, so a couple of things about standard form. Anytime you have an equation in standard form, you want to graph using x and y intercepts. If I ask you to put something in standard form, you need to make sure that x is positive and that x and y are on the same side of the equal sign. Okay? The reason why we work so much with standard form is because when we are doing word problems, it's typically a little bit easier in some situations for us to put the problem in terms of standard form. So we're going to do one problem together, and then I'm going to have you guys do the next one on your own. So number 12. A media download store sells songs for $1 each and movies for $12 each. I think that's some important information, so I'm going to underline it. So songs are $1 each, movies are $12 each, and then it says we have $60 to spend. Write and graph an equation that describes the items you can purchase. I'm just going to do an equation. That's your question. There's a second question to this. What's the second question? What are 3 combinations of numbers of songs and movies that you can purchase? Okay, so that's what we're going to do here. Okay, so writing an equation from this is pretty straightforward, and it's pretty intuitive. It's kind of what you would be doing on your own. If a song costs $1 each, what would we multiply the number of songs by to get the total cost? Well, X, or you guys want to use X and Y? Or I was going to use S and M. We can use X and Y. So if X is the number of songs, the variable that represents the total cost of songs is just X, because they're only $1 each, right? So if Y is the number of movies, what would I multiply Y by to get the total cost of movies? By 12. So X plus 12Y. And I want that to equal how much? 60, because I have $60 to spend. So this is in standard form, right? So we can figure out the x and the y intercepts from this using your t-table. So on my t-chart, let's do it off to the side. On my t-chart, I get my x-intercept as x plus 12 times 0 equals 60. So x equals 60. My y-intercept is 0 plus 12y equals 60. So 12y equals 60. And when you divide by 12, you get y equals 5. Okay. Here's the thing about these graphs. We need to label the axis. We need to label our scale because for sure I'm not going to be able to do by ones on this one. My x-axis is the number of songs. Now, I already did this problem. So I did each line is 5, but I'm only going to label the 10s. So every other one is by 10. 30, 40, 50, 60. And then 90. And the y-axis is our number of movies. So you are expected to label, and it is worth points on the test. And my y's, I could go by ones, and that would kind of squish it all together. I did every other was a 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You can do whatever scale you want, just as long as you are labeling so that I can tell what you did. Okay. So we would graph this using intercepts. What was my x-intercept? 60. So we put a point at 60, 0. And what was my y-intercept? 5. So I put a point at 0, 5, and then I connect them. I'm going to try using the line feature. Because I think that's about right. Because how we're going to find the combinations or the possible combinations is from the line. So what this line represents is any possible combination of songs or movies that you can buy for $60. So every combination that you can purchase is on this line. There's 2 really easy ones that you can figure out. What are 2 easy combinations? Any ideas? Yep. 5 movies and 0 songs. And then Karina, what was the other one? Yep. I'm going to keep everything in the same order, though. So 0 movies and 60 songs. Does everybody see where she got that from? Is everybody okay? So the intercepts, those are possible combinations. Did anybody find another one? Is 2 songs 35 movies on there? Jen, is that what you're going to say? Okay, so look here, 2 songs, 35 movies. So we can say 35 movies. How many songs? 2 songs. Did anybody come up with anything else? Christian, what else did you come up with? 3 movies, 24 songs. That is on there. Oh, did I mix it up? It's 35 songs. Oops. That's a lot of movies. 35 songs, 2 movies. And then Christian found 3 movies, 24 songs. Did anybody figure out how many, if I bought 4 movies, how many songs I could get? It's either 10 or 11. It's somewhere really close to there. I think it might be 11 or 12 songs. Okay? But basically the idea here is that the line represents all possible combinations that you can purchase. Okay? So we have a similar problem on 13 about t-shirts and sweatshirts. I am going to skip that one. And let's look at the very last part of this, which is checking points. So I do suggest that you work on 13, but for the sake of time, we're going to just look at 14 and 15. So checking that a point is a solution to the graph. On the previous example, a point is a solution to the graph if it lies on the line, right? Which means that I have to be able to plug in the x and y and get a true statement. So to check that a solution that a point is a solution, we plug in the x and we plug in the y and we look for a true statement. You can use that in the previous example to check that you got the right coordinates or the right combinations as well. So for number 14, is the point 1, negative 2 on the line? 1 is the x coordinate, so we're going to plug it in for x. Negative 2 is the y coordinate, so we plug it in for y. So negative 2 equals 3 times 1 minus 6. Let's do it. What's 3 times 1? 3 minus 6. And guys, what's 3 minus 6? Negative 3. So does negative 2 equal negative 3? No. So does that point lie on the line? No. So we would say no. Let's do 15 together. So 6, negative 3, and we want to see if it lies on the point y equals negative 2/3 x plus 1. So I'm going to plug in negative for y. So that is negative 3 equals negative 2/3 times x, which is 6, plus 1. And this is where I want to make sure everybody is good, because this is where I have seen most of the errors on homework and quizzes and things. 2 over 3 times 6. That's the same as 6 over 1, right? And we can cross-reduce here because we're really multiplying and dividing. How many times does 3 go into 6? 2. What's negative 2 times 2? Negative 4 plus 1. What's negative 4 plus 1? Is that a true statement? So does that point lie on the line? Yes. Okay. So in the previous example, we could have checked that 35 songs and 2 movies works by plugging it back into the equation that we found. Okay, Jen? Okay, so 4 movies, 12 songs is the next one. And you can check it by plugging it back in. So I'll tell you guys right now, it would be a good idea to star numbers 12 and 13 because there is a question like this on your test. Okay? I'm not trying to surprise you. It is on your test. You can check that your solution is correct by plugging it back in. So there is a part where I ask you what is a possible combination of songs and movies, let's say. That's not the situation, but songs and movies that could be a solution. So you want to make sure that you also you use the graph, but you also plug it in, because graphing is probably the least reliable way of checking answers, because there's a little bit room of error if you draw your line a little bit wrong, okay? But that's standard form. So you can always check by plugging everything back in.